Good morning. Ladies and gentlemen of Algebra 2 Honors, good to see everybody here today. We're going to be starting on section 2.3, which is solving absolute value inequalities. And we have the essential question, what are two ways to solve an absolute value inequality? Anybody can read my mind right now? Figure what those two ways are? Graphing and equation, or algebraically. Very good. All right.
Good job, Brandon.
Yes, that was very, very excellent.
Let's go, Brandon.
So we have the first section here from our book, which is exploring, and you don't need to write down every single thing here, so just kind of follow along and try to stay open-minded and make comments on this like you did yesterday. Thank you yesterday for your participation. That was a good class yesterday, I thought. Thank you for that. Anyway, what we have is we determine whether each of the integers from -5 to 5 is a solution of this inequality, and write yes or no for each number on the table. And so we're going to take, if we take -5, and I'm just going to write down, if we take -5 absolute value plus 2, is that going to be less than 5, question mark. Absolute value of 5 is what? Absolute value of -5 is what? 5, right? Is 5 plus 2 less than 5? No. So this is not a solution. No. Next is if we change this to -4, so that'd be 4 plus 2, is that less than 5? No. And we can see that if we take 3 and substitute along the way, that'd be -3 plus 2, is that less than 5? No, that's 5 is less than 5, right? So it's not less than 5. But then if we put in -2, is the answer going to be yes? It is, right? So yes, yes, yes. And I think this is yes. And if we plug in 2, we'd have 2 plus 2, yes. But if we plug in 3,
That's equal to.
that would be equal to, so no.
No.
No, no, no.
No.
So what we have is, we can see where we are, where the solutions are, and where they are not. And so you can kind of see, can't you, that if at 3, what you have, 3 is a not, isn't it? And our -3 is a not, and 3 is a not, but barely, because that's right on, these are what I call, they don't call this in the book, we call these boundary points.
Boundary points.
Because they are the boundary, I'll call them boundary values, because they are the boundary between what are solutions and what are not. And is everything in between these two values a solution?
Yes. Yes.
Everything in between, yes. And so this is symptomatic of something we call yes, so less than 5. So less is nest, and so and we could rewrite this another way algebraically. I'm going to show you, but do you get the idea of what's going on here? And what's happening to is, if you really think about it, when you really think about it, do we use inequalities in real life? Yes. If you really think about it, how did you think about it? Why did you mention it?
Think about like when you're going shopping, like you say you have a budget, it's like $200, like you can't spend over $200.
Yeah, and so that's right. And so you say spending, and that was a good example at least. So spending, I'll call it S, has to be less than or equal to, and she gave the example, $200.
Bucks.
And, but that's it. Another thing we have is that you look at tolerances. If I go ahead and cross the street and I'm trying to try to avoid hitting by the truck, that's an inequality too. I can get there sooner, but not at the same time. I want to be less than or equal to. Not less than or equal to, less than, right? Less than. But that's an inequality too. So if you kind of think about it, for reality, the way life and works and physics works, your inequality is really what you deal with most of the time when you think about it. Okay, let's go on to our next section. That was good. Now we're going to go ahead and deal with another one. Here we have absolute value of x plus 2 is greater than, and so it's going to be the same sort of thing, but instead of less than, greater than. And so if we go ahead and substitute all these numbers in here, if we put -5 in here, and that turns into 5, 5 plus 2, is that greater than 5?
Nah.
Yes, it is.
What? -5 plus 2.
Okay, let's write that out. Marcus has a question about it.
5 plus 2.
Oh, absolute value, yeah.
Is that greater than 5? Yes, because that's 7, right?
Yeah.
And likewise, if we put in 4, that's going to be -4. -4 plus 2 is going to be yes.
6.
But then if we plug in -3,
No.
no. And so what we have is we have no's all the way here, don't we?
Yeah.
Up until when?
Positive.
Up until positive 4, right?
Yeah.
Yes. Yes. But do you notice that our boundary points are still the same, which would be the -3, +3? That's a boundary point,
Yup.
and that's a boundary point. But which way are we drawing the arrows now?
To the outside.
To the outside. Okay. And this is symptomatic of an inequality expression that is greater than. So sometimes what you'll see is you'll say x is less than -3, or x is greater than 3. That's how you write it sometimes. Okay? All right, and we're going to continue talking about these things. Okay, state the solutions of inequality and relate them to solutions you found for steps A and B. I'm going to kind of skip that. It's fresh in our mind. Okay, if x is any real number and not just an integer, graph the solutions. And what I did is I actually did that. We had the less than was this, right, between them. And the greater than was this. So that's what those look like. Okay, so we go on here. Okay, and then reflect. It's possible to write these inequalities using inequalities that don't involve absolute value. And here we see, and we're going to just go on from there. Describe solutions and inequalities that don't involve absolute value. So greater than 5, less than 5, we're going to skip that. Okay, we're going to get to graphically here. Solve inequality graphically. So you have this inequality here, and does this look familiar to the last section we were looking at?
Yeah.
Where you would have g of x is equal to 4, which is going to be right here. And we have f of x is equal to this thing right here. It lies above. And so that's going to be this thing right here. Okay, and so we say greater than 4, and so where do we see this graph here above this graph of 4? Where do we see that happening? Well, we see it over here to the left, and this is going to be, these are going to be our, these are going to be again our boundary points. Remember I talked about boundary points a minute ago?
Yeah.
And so in inequality, you know your answer is going to be these values in here or the values to the outside. So what do we have here? These values here between -6 and 0 are the values outside of -6 and 0.
Outside.
Okay, Siggy says outside. Is he right about that? Yeah, he is, because what it is, we're looking for greater than. So it's this area above where we see that function above y equals 4 that are the solutions, which would be over here, greater than 0 and less than -6.
Yeah.
Okay, so that's a graphical solution, and what do you have that can help you with those graphical solutions?
Calculator.
The calculators. Okay.
So smart, bro. Facts.
All right, really good. Next they're asking us to really to graph one to see what it looks like. And so we have, in this case, absolute value of quantity x minus 2 minus 3 is less than 1. So how do we do that? How do we graph this thing right here? Will we find a vertex for the one on the left? Yeah, what would our vertex be for this one on the left here?
2 -3.
So Marcus says 2, -3, is that right?
Yep.
Yeah, that's right. And what is our slope for this thing?
1.
1, A is 1, so the thing's gonna look something like this, right?
Yeah.
And then like this. Okay, that's,
Think straighter than me.
all right, so we have that, and then what is the other function we graph? This 1, right? So 1, so here we draw the 1. Let me draw it a little straighter if I can. Okay, and we're also, we have less than, so so are we interested where the graph is below or above? As below, okay. Does everybody see that? Everybody see that? Below, right? And then the graph lies below the graph. I think that's below also. Between x equals -2 and x equals
No,
6. And so we conclude here that we have, let's see, x is less than, we're below, right?
Yeah.
Less than 6, but greater than -2. So that would be the visual confirmation of that. All right, graphical. Now, the next thing we're going to do here is, okay, they say, what if we had greater than, what would happen? How would the solution change? Well, we'll go to that eventually. What I want you to do is to solve this one graphically. Now, I realize you're not given graph paper for this, so you have to sort of draw this out. Or if somebody needs to borrow graph paper, I happen to have some here. I don't know if you need that, anybody.
Okay.
We good.
You good on that?
Yeah, we did.
Haley, need any graph paper? And I want you to go ahead and solve this graphically. Try it. Work on this. Try to sketch it out by hand. But then you have a calculator also, right?
Yep.
Yeah.
See what I would do. I'm just gonna sketch out a coordinate plane here a little bit. X, Y. 1, 2, 3, 4, 5. I find when you do these kind of free-handed, you can generally get, it's kind of close by just eyeballing it. I'm seeing a lot of right hands going to work and one left hand going to work.
Who's left-handed?
Cheyenne?
I'm different. I'm left-handed.
You're a lefty.
I'm left. That's why I get
About, do you have hard?
ink all over my head.
Yeah, because we have to write over it. Yeah, and also it's like,
And I'm right-handed.
I'm not left.
Mosquito.
do you ever, Cheyenne, go like this with your left hand so you won't write on it?
I tried, but it doesn't really work out.
Doesn't work out well.
But
Yeah.
I have to like turn my paper.
You're left-handed?
Okay, yeah.
You're left-handed?
I'm just like having right-handed.
I'm not left-handed.
I was
I can barely write with my left hand.
left. Your sister's left-handed.
My sister? Which one?
She's left-handed.
No, she both of them are, yeah.
There's
Sex?
an odd one now.
Facts.
Yeah.
Do you weird when I write with the left hand?
Everybody in my family is
I'm doing
left-handed.
left-handed.
Except you.
Why? My sister.
Sisters are.
Yeah, sister.
Yeah.
My mom, she's both, cause she's right-handed, but she broke her arm when she was little, so she can write with her left hand.
Yeah, my,
And then my dad's like me, he can barely write. He make can barely read too.
He blind?
He's blind, he's just dumb.
Okay, Maddie, you.
Like, we're dumb in school, but we're smart outside, you know, like doing stuff. And my sister and mom are smart in school, but they're dumb.
How much?
You do that
Then
one?
she came to my.
okay, let's look at this here. Did you finish this?
Yeah.
Okay, so I'm gonna graph this -2 first, right here.
Yeah, that's what I did.
I already did that, bro.
Yeah.
So I'm gonna say y equals -2. And then the next thing we're gonna do is graph this thing right here. So what is gonna be our vertex here?
-1.
-1, -4.
-1, -4, right?
Yeah.
So -1 and -4 like this.
Yeah.
And the slope is 1.
And so slope is 1. So you're gonna go like this. So you went through our y-intercept of 3, and then our x-intercept is also gonna be 3. That makes sense?
Yeah.
And then going the other direction is going to be a little bit harder to visualize, but it would be like going from like -5 up to here, something like, whoops, let me get it straighter if I can.
Yeah. Straight like Mark.
Why is it negative?
Straight like Eddie.
Because like on the other one, that was just, it was positive.
Oh.
Okay, so these would be our boundary points right here.
Pull up the number.
So boundary points,
Calm down, Jamal. Don't pull up the number.
so I think this one here is supposed to be at -3, is that right? So I think that's -3, comma -2, and this one over here is easier to locate. This one's going to be 1, -2, is that right?
Yeah.
So there's 1, -2, here's -3, -2, and so we say less than or equal to, so where would we find our solutions?
In the middle.
But in the middle?
Yep.
Yeah, so we're going to find the middle section right here would be our solutions.
Yeah.
And so we would say, x is less than, is it also equal to also?
Yes.
Less than or equal to 1, right? And, but greater than or equal to -3. And so when you have less than here like this, you're going to be able to write that as a single inequality with 3 elements. Okay, a middle element, where's the variable, and then the extremities below that and above that.
Got it.
Okay, so the thing's going to look like that. Does that make sense to you?
Yep.
Yeah.
Did anybody get something different than what I did up here?
Yeah.
You got that exactly? Okay.
Yes, sir.
Okay, good.
X. Where what?
See what's going on here.
One.
Okay, now we're segueing to our solving algebraically, which is like, who said the equation? Was Braden or Jose? Talked about the solving equations, right? Was Jose? Yeah. And so, anyway, what this does is it takes you through an example showing you everything they do here. First thing we have is subtracting 15 to get to this, right? So you take this inequality, minus 15, you get 6 here. And then this is going to be or. And when you have a greater than, I like to call this more is or. More is or. That means you're going to have 2 separate things. One for less than, one for greater than. And it's just, this is going to be less than the -6, but greater than the 6. So do you see that? And then when you solve these, you get this situation here and end up having on a number line solutions that look like this. And then here for B, they're asking us to fill in some blanks. So let's go fill in some blanks here. We have absolute value of quantity x plus 4 minus 10 is less than or equal to -2. What do we do here? Add 10. So what's -2 plus 10? 8. And then we have x plus 4 is greater than or equal to 8 and less than or equal to -8. But I think that's wrong. I think that's wrong. Let me fix that. Yeah, this is going to be -8, greater than -8. Thank you for pointing that out. And less than or equal to 8. Thank you for pointing that out again. Okay, so if we solve this, we subtract 4, so we get -12. So we're greater than or equal to -12. And when we subtract 4 here, we get 4, 8 minus 4. So we have x is greater than or equal to -12 and less than or equal to 4. And so now we can graph these on our number line. And are we talking about the open circles here or the closed point? The closed point. And this -12 and 4, the closed point is going to be right here and right here, is that right? And then right in between the two. Yeah. So we have it right there, okay? And then we have, then they give a supposition here. We won't go to that. Okay, I'm not going to do there, okay. Solve the inequality algebraically. And so I want you to look at these right here, the your turn, and just work at those and see how you do on those. Can you do that?
Yep.
Yeah, I got you.
And I want to tell you, I want to remind you of what I told you before. One thing that can help you is something called more is or.
More is order.
And less is what?
Stress.
Is nest.
Nest?
Less is nest.
What? What is that
Like a
supposed to
bird
mean?
nest?
Kind of like a nest. I'll explain what it is later.
Oh, because it stands or something?
But I'll just, yeah. But what it is, this is a memory aid. You know the little songs and things I've been having you do and all that? This is one of them. More is or. Less is nest. It's like a chant. It's a mantra.
Gotcha.
More is
You're gonna have to
or.
chant
Bex.
that.
Less is nest.
My mind is
Just sing it.
Just sing it.
More is or.
Is
Less
there a song
is
to that?
nest.
Did we subtract?
Like talk.
No, you got subtract, right?
You got the mark? You got it, Mark?
Yeah.
Let me see.
At least.
What? What, I have no phones.
I see a lot of right hands at work and a left hand at work.
Thank you for pointing me out. Appreciate
Good
it.
for you.
No, I stand out, don't I, Mr. G? I'm left-handed.
Yes.
Are you? Yes, actually, I eat with my left hand. I write with my left hand. I brush my teeth with my left hand. I don't shoot with my left hand. Do it with my right hand.
Do you know that we've had 3 pretty recent presidents of the United States who are left-handed?
Me,
Really, so you
Donald
think you
Trump,
want to be next
and
president?
Siggy.
No, they were Bush 41. George H.W. Bush was left-handed. So was President Bill Clinton, and so was President Barack Obama.
What about Donald Trump?
I think Donald Trump's a right-hander.
Mr. G, do you think I could be president?
Yes, you could. I will say that.
You look like Hillary.
I will say that.
I didn't say
Yeah, I think I'm just gonna stick to orthodox.
Okay, let's go ahead here. How would you solve this one on the left?
Me is
that. Can you fix my teeth?
Divide by 3, right? So we have absolute value of, so we have 3, right? So how do we, is this going to be more as or?
I don't know how
It's going to be less than.
More is or, greater than, more is or. So that's going to
I
be,
don't know what it is. You won't tell me.
that's going to be,
Or what?
Mr. G, shut up. What do you mean by or? Yeah.
I'll show you. Or means you have two like expressions. Let me show you. So what you're going to have is you're going to have an or right here. So you're going to have,
So we're effective?
you're going to have x minus 7 is greater than or equal to 3, or x minus 7 is less than or equal to negative 3. That's what or means.
Mr. G, we can.
Why'd you put the sign?
Pardon me?
Why'd you put the sign?
What do you mean? I don't understand your question.
The sign on the negative 3.
Oh, here?
Yeah.
Okay, I had a question, and this is a very good question Marcus had. Said, why did I switch the sign? Okay, pardon me?
It's negative.
Let me tell you why. Let me tell you why, okay? What you're doing when you switch the sign, it's like you're dividing by or multiplying by a negative number, right? And so when you make the thing negative, what do? You switch the direction of the inequality. So that's how this one became negative. So that was just an awesome recognition there of that. Good job. Good job, Marcus. Yes.
You get the gold star.
You get a kiss,
so-
Mark.
You have a gold star.
So we have here, we can mark this on a number line. Oh, we haven't solved it yet, have we? We have to add 7. So if we add 7, x is going to be greater than or equal to,
Oh,
I'm thinking 10, right?
Right.
Or, what do we have here? If we add 7 here, what do we get?
4.
So we have x is less than or equal to
4.
4. And so we're going to put greater than or equal to 10, and we're going this way,
Yep.
or less than or equal to 4. Yeah, one thing you can do is you can test boundary points and just go back in and say, what's a point in between these two? 6, right? So 6 shouldn't work.
6.
If we try 6, well, we would have 6 minus 7 is going to be what? Negative 1. That's going to be 3 times 1. Is that greater than? No. So you can test the boundary points too and all these. So these would be our, so what we have here is x is greater than or equal to 10, or x is less than or equal to 4. So that's why we have or, because we have 2 intervals of solutions. Does that make sense?
Yes.
So, or, it's something, you could say and too, right? But or is just sort of conventionally what they say more often. Now this, pardon me? What did you say something?
I don't get it.
Okay.
I don't understand.
Okay, what we did is we took this one right here and we separated into 2 phases. We took away the absolute value brackets and we made this greater than or equal to 3. And here we took away the absolute value brackets and made it less than or equal to negative 3. And we just went and solved these.
But so the one, when you have a lesser than symbol, that means you won't have more?
Yeah, so Chloe just asked the question, if we don't have the less than or equal to symbol, does it mean we have a point? No. It means we have a hole or an open point, right?
I thought it was a close.
Or a location. She's looking ahead to this one.
Okay.
She's looking ahead to this one. Okay.
What was the next year, just this one?
Okay, so now we're to less's nest. Let me show you how this works. What we have, we take away this, so we have 2x plus 3 is less than 5, and what goes over here is greater than negative 5. So what we have here is we have a section, it's not or, we have a single interval wedged in between the 2 extremities.
Got it.
So it's an inequality that has 3 pieces to it. Over here on the left, in the middle, and on the right. And this, where is our unknown located, our variable, or it's right here.
Why'd you write it like
X, right?
It's x, yes, Yeah, so this is our unknown that we solve for, and it's in the middle piece. Here, what happens, we have nothing in the middle, and we have our solutions here to the left of this point and to the right of this point. And so now what you have, you can solve like an equation. So what you do is you can subtract 3, and where else do you subtract 3? Over here and over here. Okay, so we subtract 3 from each of these intervals. Do you see that? No?
Oh,
okay.
Right? And so now we can take negative 8 minus 3, which is, or negative 5 minus 3, thank you, I was thinking ahead, which is negative 8. And that's going to be less than,
2x.
we have 2x, which is less than 2. And what's the last thing we can do?
Divide by 2.
Divide by 2. We can divide everything by 2. And what do we have left here?
Negative 4.
So we have negative 4 is less than x, which is less than 1. And so now we get to Chloe's observation about so we draw a point here or open.
Go Chloe.
Open. Okay, so open. And here we have Les's nest. Because what it is solution set is nested, right? Nested in between the extremities. Does that make sense?
Yes.
I'll just write it between extremities.
Thanks.
Yo.
So that's really, so we'll just leave it there today. Thank you. We're going to work on some exercises, I believe, on Monday.
Monday, yeah, sounds good.
Monday.
As for how many